What if I told you that in the time it takes you to blink, just one single blink, an explosion somewhere in the universe releases more energy than our sun will produce in its entire 10 billion year lifetime? Not a week, not a century, the entire lifetime of the sun gone in a blink. That is not science fiction. That is a gamma-ray burst, and it is the most violent, most powerful event the universe has ever produced since the Big Bang itself. Now here is where it gets controversial, and I need you to stay with me on this. Scientists have been studying these explosions since 1967, and we still do not fully understand them. We have sent satellites into space. We have built ground-based telescopes worth hundreds of millions of dollars. We have dedicated entire careers to chasing these flashes of light across the cosmos. And yet, gamma-ray bursts continue to surprise us, humiliate our assumptions, and rewrite our textbooks. The universe is clearly keeping secrets, and gamma-ray bursts are one of the biggest. Let us start from the beginning, because the discovery of GRBs was itself one of the most unexpected moments in scientific history. In 1967, American military satellites called Vela satellites were orbiting Earth. Their job was simple: detect nuclear weapon tests by the Soviet Union. But instead of catching nuclear explosions from Earth, they detected something coming from deep space. Flashes of gamma radiation so intense that scientists initially had no framework to even explain what they were looking at. The Cold War accidentally handed humanity one of the greatest astronomical discoveries in history. Fast forward to today. We now detect approximately one gamma-ray burst every single day somewhere in the observable universe. Every single day. NASA's Fermi Gamma-Ray Space Telescope and the Neil Gehrels Swift Observatory are constantly scanning the sky, catching these bursts in real time. And each one of them represents the death, or sometimes the violent birth, of something extraordinarily massive. Here is the pattern interrupt that most science channels will not tell you. Not all gamma-ray bursts are the same, and this distinction matters enormously. There are two main types. Short GRBs last less than 2 seconds. Less than 2 seconds. Yet in that window, they outshine the entire observable universe. These are caused by the collision of two neutron stars, or a neutron star merging with a black hole. Events so catastrophic that they also produce gravitational waves rippling through the fabric of space-time itself. In 2017, scientists observed GRB 170817A alongside gravitational waves for the very first time, and that single moment opened an entirely new era of multi-messenger astronomy. We were no longer just seeing the universe. We were hearing it. Then there are long GRBs, lasting from 2 seconds to several minutes. These are born from the death of massive stars, stars at least 20 to 30 times larger than our sun, collapsing into black holes in events called hypernovae. The star does not just die quietly. It dies in a rage so spectacular that two focused jets of gamma radiation are fired outward at nearly the speed of light. If one of those jets happens to point in our direction, we detect it as a gamma-ray burst. Think about that. We are only seeing the ones aimed at us. There are countless more happening right now that we will never see because we are simply not in the line of fire. And this raises the question that should make every human being on Earth pause and think. What if one of those jets pointed at us? What would happen? This is not fear-mongering. This is established science. A gamma-ray burst occurring within approximately 6,000 to 8,000 light-years from Earth and aimed directly at us could strip away our ozone layer within seconds. Not gradually. Seconds. Ultraviolet radiation from the sun would then reach Earth's surface unfiltered, devastating ecosystems and potentially triggering a mass extinction event. Some scientists actually believe a GRB may have caused the Ordovician mass extinction approximately 443 million years ago, which wiped out nearly 85% of all marine species. The universe has already fired at us once. We just did not know it until recently. But here is where the story shifts from terror to absolute wonder. In 2022, on October 9th, a gamma-ray burst designated GRB 21009A struck our detectors and left the entire global astronomy community speechless. Scientists immediately called it the brightest of all time. It was so extraordinarily energetic that it saturated almost every gamma-ray detector in space. Instruments literally could not handle how bright it was. It originated approximately 2.4 billion light-years away, meaning this explosion happened 2.4 billion years ago, and its light is only reaching us now. It disrupted Earth's ionosphere, the layer of our atmosphere that makes radio communication possible. An explosion 2.4 billion light-years away physically affected our planet. The sheer scale of that fact should rewire how you think about the universe. And yet, despite everything we know, GRB 21009 still produced photons of energy that our current models of physics cannot fully explain. Particles with energies exceeding 18 teraelectronvolts were detected. That should not be physically possible according to what we understand about how gamma-ray bursts work. The universe handed us the most powerful explosion ever recorded and simultaneously handed us a problem we cannot solve yet. This is why gamma-ray bursts matter. Not just because they are violent, not just because they are distant. They are the universe's way of telling us that our understanding of reality has edges, and beyond those edges, there is something extraordinary waiting to be discovered. Follow this page right now, because we are just getting started uncovering the secrets this universe has been hiding in plain sight. Now tell me, does it change how you see the night sky knowing that at this very moment, a star somewhere is dying in the most violent explosion the universe can produce, and its beam of energy could be traveling toward Earth right now?